the quantum computer can quickly solve the cryptographic informations. Then you can actually co-simulate all together at the same time. This will make things much, much easier. I used to design an aircraft. It's very complex. If you don't do that, I think it is impossible to actually connecting to other systems. This is what I call that the digital evolution. You must done in the first place.
Hello and welcome to Prostep ivip Push to Future. I'm Adachi from Mazda Motor Corporation and a member of the board of Prostep ivip. Today I'm visiting Toshiba Headquarters in Japan and talking with CEO Shimada-san regarding to the kind of hot topics and the industry, very important things, the quantum computing area. We are focused on these three topics. The one is a software-defined business transformation in Toshiba. The second is the future created by quantum technologies. The third one is the evolution of AI in system engineering.
Hi, I am Taro Shimada. I'm a CEO of the Toshiba. Well, I started my career with aircraft engineer. I was designing aircraft for 10 years and been to Boeing and others. And after that, I joined a software company, American companies, working there in 10 years. And that company was acquired by Siemens. So I actually worked in Siemens in Stammhaus in headquarters too. Then after that, I come back to Japan and joined Toshiba 7 years ago. This was my best decision that I made. Well, job of the CEO is actually leading a people to the right direction and optimizing the problem for the future. We were focusing on to solving the biggest problem of the human nature, which is the sustainability.
I'm in charge of the digital transformation of Mazda All, not only R&D, but also the finance and the personnel or marketing, every whole company activities. My most proud of things is the model-based development lead in Mazda R&D. So this is a very successful activities in these 10 years, our activities. So now our productivity is so high, incredibly, based on our size of the company. So Shimada-san, thank you for coming to the Push to the Future.
My pleasure, yes.
Thank you very much for this type of very precious time and rooms, facility. Yes. So first, what comes to mind when the reader or audience hear the name of Toshiba, company name Toshiba? If you think heavy electric equipment, then home appliance and semiconductors, you are probably a little older. Toshiba is an IT solution company that is focusing on the realization and socialization implementation of quantum computing. Today, I'd like to ask CEO Shimada-san about this point in particular. So now the software-defined blah, blah, blah is a kind of buzzword. So the software-defined business transformation in Toshiba. So what is the scope and how to approach? Could you talk about this?
Yes. Well, thank you very much for the kind introduction. Yes, we do all kinds of stuff. And, our company's motto is that the purpose is something called committed to people committed to the future. But in Japanese, this is a little bit more detailed, which is for the people, for the planet, and for the future. So from that perspective, this is a really great purpose, which we already have from 1990s. So we have over 30 years that we're working on this purpose. From that perspective, this is not limited to that, heavy energy industries, anything like that. We can do anything if we can be able to help the sustainability of the people. So now we are focusing on, just like you introduced, that the software, and then also the digitalization, and the next level is the quantum that we are thinking. The first step that we need to do is the software defined, which we focusing on to change our product so that the software-enabled product. Meaning is that the old product is usually that you actually have a software inside of the hardware and then you ship it to you. Maybe automotive car is also similar way. All those embedded softwares works perfectly fine, but this is actually embedded into the hardware itself, which is car. But we wanted to separate this hardware and software. It's more like software is wrapping around the hardware so that you can actually be able to connect your hardware after you actually receive the product itself.
Functionality enhancement is easily applied by the software.
Yeah, exactly.
But also where the hardware is a real hardware.
Yes.
It's really required
Yes,
from the product development company point of view.
Of course.
Yeah. So that more freely, more enhancement, more friendly.
Yeah.
That is the point.
Yeah. So it is important to divide that the software layer, which defined to capability extended to the digital. And then also that you have to keep some of the key component inside of the hardware too. So that let's say that the safeties and then all those important features have to be very quickly reacted for the hardware. But at the same time, you need to have that additional capability or new technology updated continuously. In order to do this, you need to have a different software layer wrapped around the hardware.
So really, in the automotive area, software-defined vehicle is now buzzword.
Yeah. Yes, I understand.
But we apparently clearly understand the hardware react safely. This is also one part. Additionally, as expansion of the connecting the world is two part as we must consider. That is the point.
Yes.
Okay.
But the next level is something what we call that. This first level to separating hardware and software is what we call digital evolutions. It's just the extension of what we are doing right now, enhancing a digital capability around the hardware. But the next level is the digital transformation. What we defined is those software have to be becoming a platform, so that easily you can actually access to the other software, which even you don't really develop by yourself, and somebody else software or somebody else hardware can be also connected to this software layer. So becoming a platform. When you get to the point, finally you can say that this becoming a digital transformations. Yeah.
Okay. So do you have an example or such kind of realization, conceptual realization? So I've heard of the Shibuya approach or something like that.
Yeah. So the first level, the digital, the evolution, let's say that in elevator, you might wonder why you cannot call the elevator using a smartphone, for example, which today is not possible because all those software is actually, embedded inside of the hardware. But we actually define that, the safety and basic function layer and then software separated, so that those important feature of elevator can be accessed through the API, which open up all kinds of different applications.
Okay.
For example, that some of the people who has rich people, maybe he's not happy about that stopping an elevator every single stairs. So by just identifying that who is inside of the elevator doesn't stop. You can configure any way you want. Or you can actually work together with the robots, which actually observing the safety and things like that, which is nice. But I mean, if you want to have a 30-story height, do you really need to have 30 different robots in each individual story? By having this API integrated in elevator, you can actually, robot can actually call the API and then go to the different story and stair. And then you can actually just get out and do your things and all kinds of service all of a sudden that you can expect.
Okay, so this means that so hardware, so the connecting to the or whole world via the API.
Yeah.
That is a point.
Yeah, but when it's going further, this software is available to many people. Maybe we can actually control that other brands elevator too, and then finally you become like Toshiba elevator. They used to sell the elevator. But now they are actually the platformer who are actually connecting hardware each others.
So the second topics I would like to talk about now the quantum computing area.
Yes.
So the 1 month ago, so the Japanese Institute RIKEN announced that quantum computing on the gate type is realized.
Right.
So now everyone's understanding is quantum computing realization is future. So this is not realized now. The technology evolution is so fast is my understanding.
Yes.
So the future created by quantum technologies.
Yes.
What is the scope, but what is the future we encountered for now?
Yeah, the quantum computing is very amazing. And then also that the rapidly growing and rapidly enhancing. When I becoming a CEO, and even before the CEO, 2020s early, they said that it's going to be a 2050 to have real quantum computing, but people talking about 2030s these days. This is just amazing progress that we're seeing. But what quantum computing is bring is the huge amount of information quickly optimized, and then all those very difficult calculation, which is not possible to using a current hyperscale computer, can be solved very small amount of the time. Especially that, when you looking at optimization problems, actually, even today, we have quantum-inspired technologies, which is actually using a quantum technique or quantum mathematics, so to speak, applied into the normal computer. So you can actually use even inside of the FPGA. And then you can do the quantum type of one certain quantum type of the calculation, which is combinational optimization.
Yeah, computational technology is so latest, the current technology.
Yes.
Yeah, but the algorithm or method is completely different, inspired by the quantum.
Yeah. So, for example, the way that the quantum computing is calculating is using more of the physics method. So in a digital, you actually, let's say that you want to find out at the lowest point in this kind of area. You have to measure everything in a digital. So it takes some time. But quantum computing is just, dropping a water, and then water is dropping into the hole.
Yes. Yeah. Now
the physics way to solve the problem.
Annealing type of quantum computing
yes. So it's a very quick and then very processable for the vast amount of the information. And this is actually extension of digital transformations. But current digital transformation is still limited to that by industry or by some of the categories, some domains, so to speak. But by using a quantum computing, you can actually do the cross-domain optimizations. So this is always a problem of even the designing a car or designing a products. It's always a problem. Also that when you have 10 million people is living and working and moving and all those kind of things, and how you can actually get the optimized solution for individual person. It's really difficult problem to solve. But quantum computer can do that.
Yes, computing algorithm or such kind of things is important.
Yes.
The other important area is, my understanding is security assured or such kind of area is the most important area.
Well, thank you very much for mentioning that. Because the quantum computing, by having this, the quantum computer can quickly solve the cryptographic informations. So current cryptography will be broken once the real quantum computer is coming. Well, we have a countermeasure using a quantum key distribution, which is using the photon to send the crypto information over to one place to the other, which makes it impossible to steal the cryptographic informations. So this is the ultimate the safe measure against the one of the downside of the having a quantum computer, which you can actually solve the very complex cryptography too.
Okay, so security. How to secure the security thing? So you are the QKD, quantum distribution, key distribution. It's a one key technology you have. But this is also basis hypothesis is photonic communication is a basis. Okay. So this means that realizing the quantum era. So now the hardwire communication to the photonic.
But not necessarily. For example, that free space, the quantum transformation is possible too. So, for example, that the satellite communications using QKD is also that we are working on this, and then also that there's many experimental is going on.
Okay, so very promising. What type of future comes when the connecting whole world by the quantum technology?
The quantum technologies, one of the good thing is that they are very efficient way with the computational. And then also that the solving a problem very quickly. So, the things that we thought that is not possible can be solved. But at the same time, I think it's kind of helping the AI, the progress by having a quantum computing too. Because today's AI is consuming so much energy and so much GPUs and so much data.
Electricity supply is crucial for the future application.
But quantum can be one of the solution to solving such a problem too.
Okay, very interesting. Thank you very much. So next is a kind of game we play. So finish the sentence. From now, I give Shimada-san the sentence to finish. You have a couple of seconds to answer the questions. AI will be
our infrastructure.
Your biggest failure you learned from was?
I didn't have one.
So S1 last. Cooperation between European and Japanese
will set the standard for the future.
Your biggest success is?
Join Toshiba.
Industries cannot survive without
ecosystem.
Japan is
very stable and reliable, punctual.
Okay, thank you very much for a nice answer. So the world can benefit from Japanese knowledge in case of collaboration. You answered. Could you deep dive in this or explain more, please?
I think our language is very vague in a way that there's something what we call the high context language. We spend enormous amount of time together, sometimes drinking and sometimes fighting, but at the end of the day, spending all those times actually paid off because you can feel what's really he wants or she wants or they want, and then it's become all of a sudden very super speed to solving problems. So sharing a mindset and sharing informations. In the digital world, the SNS and others actually creating a new type of data connections, which has a unique type of informations. But the end of the day, it is just a tool to connecting people, to fostering collaborations. People cannot survive by yourselves, even though, some of the people might think that I'm just fine by myself. This is not designed to it. Human is not designed to just the social being. So the collaboration is absolutely necessary. And then as you can see, if you come over to Japan, the very safe, very stable, very punctual. Maybe some people might think that we are a little bit behind the digital or things like that, but we are taking things very deeply and then integrate into it. This is collaborations. If you cannot do that, I think the people will be divided and then also sometimes just broken down. So this is what I meant by the collaboration.
Okay. Yes, thank you very much. So the now is also geological economics
Yeah.
is so now hot topics.
Yeah.
In this era, so the much more collaborative work is so important, isn't it?
So this is more like to me it's a quantum.
Yeah.
It can be 0, it can be 1. There's no such thing like yes or no. There's always things like yeah, you might think so. I think this way, but we'll have to accept. Dividing a word is the last thing you want to do. We want to collaborate peacefully.
Okay. Yeah. Thank you very much. Yeah. So now the AI is also variety kind of AI technologies coming. So especially for the ChatGPT or large language model is now booming. As and also the industry point of view, systems engineering apply as a kind of also the boom. So or necessary. Yes. For that scope, so how the impact on the AI on the systems engineering. So could you give me some explanation, a scope, please?
Yeah, I think AI will be the infrastructure, almost like people must consume and people must use, and for the optimization and automations, and quickly that the decision making process. Helping the decision-making process by using AI. In order to do this, I think it's very important to have that the structured information, meaning that the system engineering and system of system, you need to actually breaking down that the information in the right way. Otherwise, that you cannot have a really good answer from the AI too. I mean, the famous word that bad things going to AI. I try to avoid the bad words, but so you must have that the clear, the structure, and then also that well sorted information, so that the AI can consume and then you can give a very good answer to it.
Ontology based, so the sorting is very important. So also the automotive industry is same situation. Each division has its own database. There is no balancing or no well sorted. And now the booming for the using AI, but it is almost impossible to put together. Yes, garbage makes garbage only. Yeah, that's a very simple reason.
Yeah. Yeah, and also that the AI will be much more distributed AI, meaning that the many of different type of the AI requires. Some of the people who's really good at the optimizing engine or optimizing battery technologies, and then all those people have to working together very nicely, which requires some structure, and then also that the input output have to be very clearly connected, and platform required to do that.
So what is also Toshiba's approach for this area?
Yeah, that's right. We are providing such a software platform and try to promote this, something called the Venet DCP, which is the applying for the model-based design. And then we are applying all those different simulators and connecting through what we call the platform of Bennett. And then you can actually co-simulate all together at the same time. This will make things much easier. Because if you wanted to solve the entire problem by just one system, it is not efficient. It's very difficult. And then also that the people cannot learn, I like this tool, but I have to learn this tool. And it's not really possible to do. By having this type of a platform, you can actually utilizing your model and then applying to that model for maybe you never think about how you can actually be able to use your model different way. So system of system. And by having this, actually you can have a much more clean data, which you can actually feed into the AI too.
But how to utilize more effectively using? So what is the AI have a role or impact on this usage, Bennett?
Yeah, like I said, that the important point is be able to communicate the informations. Once you have those information, you can actually flow those information into the AI. Yeah. AI can learn, and then you can actually be able to use the AI for the automation to helping your decision-making process. Yeah. But the challenge is really, I think, is more of our side. The human is so used to just inside of the silo, and then just focusing on just one single things and optimize it. But the system is complex. Automotive is complex, and then I used to design aircraft. It's very complex, and you never know your small mistake or your small changes affecting completely different locations. Yeah. All those things are connected, and then affecting each other. How much influence you have, your change can be visualized. And those information can be fed into the AI. So the AI can suggest you that if you change this, you might cause this and this and this and this.
So this means AI is not the artificial intelligence, but the augmented intelligence.
Yeah, I think it's more like assistance.
Yeah, supporting us.
Yes, and the end of the day, that the human have to make a decision whether you like this car or don't like this car, or you like this feeling or you don't like this feeling, and that's something that we must make a decision.
Okay, so also the system engineering is engineering very clear understanding the structure. Yeah, that is also basis. But then now the current the system scale is so huge. And whatever type of tools, current tools use, yes, the system engineering tools, there are a variety kind of tools exist. So what kind of view? You clearly visualizing the view, but it is almost impossible to understand the human brain directly.
I understand.
Yeah, that's the point of using the AI, the enhancement of our capability, fully using such kind of tools.
I think that's a good point. But things starting from having your model or your products software defined, so that some of the interface you clearly define. Doing a software defined is more like defining your boundary conditions, how you wanted to send the data and how we want to receive the data inside of your domain functions. If you don't do that, I think it is impossible to actually connecting to other system very easily, modular way. This is kind of a precondition to be able to even utilizing AI or creating an entire system design too. So this is what I call that the digital evolution. You must done in the first place. And once you done that, then there's a platform, a software you can utilize, and then connecting each other. And then all of a sudden people start talking. And then people start seeing that all kinds of influence on the different system and all that.
Okay, so the fully utilizing the AI, so well-sorted data, the model and structure is so important.
Yes.
Okay, thank you very much.
And then start from the software defined of your small products.
Yes.
You can start even today.
the importance of the prostep ivip in the industry of today. So could you mention how was your experience and the gain for Toshiba?
Right. I mean, it is important to have an ecosystem. Although that we think we can do anything, but I mean, it's not really possible, and then also it's not economical possible. I mean, so it is important to have everybody connected and an ecosystem growing. IPIV prostep is a perfect place to creating an ecosystem, understanding all those different diversified ideas, and then talking each other, how we can actually building a future together. So this is how I see this.
So this is also our kind of final topics. So let's imagine how your field will look like in the year of 2035.
Right. It's a difficult question because I tried to avoid that to answer the question because in 35 and then I was like the people digging up my film and all those things, and Shimada-san said this and he was wrong and things like that. But we will have to update our future every day, every year, how it's going to look like. But the one thing is important is why we are doing this is much more important. Because all those technology can be very dangerous.
Yes.
But we will have to do for the people, for the planet, and for the future. If we forget about this, all those clever thinking and scientists, all those, amazing invention and innovations will killing us. We don't want to do that.
In other words, double-edged sword.
Yeah.
Good one and bad one. When we use mal-usage, so that the impact is so catastrophic. Thank you very much for taking the time for your busy schedule to participate in the valuable talking today. Thank you very much.
Thank you very much. Vielen Dank. That's it. I don't know.
Ich habe schon da nicht gelesen.
Hello and welcome to